All right, this is Mr. Wyrick, and I'm going to be going through these notes with you today. And then I'm going to get to the delta math. We're going to go through a couple examples, and we'll work from there. So right off the bat, we're talking about congruence and similarity through transformation. So all the transformation stuff that we have been doing, the reflections, the rotations, the translations, and then the dilations, like all of those are different kinds of transformations, and it's either going to make shapes that are going to be congruent or it's going to make shapes that are going to be similar. So if we look at these, it's like which shapes are congruent and how can we tell? So this one appears to be reflected and rotated to make this one. It looks like it would be rotated a bit and then dilated down, shrunken down to make this one. And then this one just seems completely like not congruent, not similar, nothing at all. So there was supposed to be this assignment with these blobs, and you were supposed to work your way through and try to see which blobs were actually the same as the other blobs and talk about what kind of transformation it would take to make one of these blobs congruent with the other blob and how you could tell. If you take a shape and you move it onto another shape in some form, rotation, translation, reflection, whatever it is, that usually is called mapping. So if we can map one of these figures onto the other ones without changing its size, then it's going to make a congruent shape, and we're going to know that those shapes are congruent. So this is the stuff that you need to add to the notes. A rigid motion transformation is a sequence of translations, rotations, and or reflections, and they're going to be congruent if and only if a rigid motion transformation can map one figure so it coincides with the other. So if we can take one of these shapes and we can rotate it or reflect it or slide it or however it is that we need to move it, and it's going to line it up or map it onto that other one, they are going to be congruent for sure. Similarity, on the other hand, we remember similarity as these things are the exact same shape, but they are different sizes. So the only transformation that we would have done that would have created similar shapes would have been the dilation. So these are the two things that you need to write down for similarity. Similarity is caused by a sequence of translations, rotations, reflections, and or dilations. And specifically, it has to have the dilations. It could have just the dilation and nothing else that's going to create similar shapes. But if we do any of these other things and then a dilation, it's just going to be similar. And they are similar if and only if a similarity transformation can map one figure so it coincides with the other. So this is a review. On Wednesday, we're going to have a practice performance task. You need to know the rigid motions, and you need to know scale factor, a way to find scale factor. So I'm giving you some practice today that's going to be this different stuff, okay? So our delta math for today, we're looking at the skills, its congruence and similarity. So the first thing is congruence via rigid motions. So we're going to try to turn, figure S into figure T. I believe this is going to be a rotation. We are going to go 90 degrees, and I would say, counterclockwise is probably going to be better. When I rotate that, it's going to look just like this. And then I need a reflection over the x-axis. And that reflection over the x-axis should make it to where they're going to match up. We've done this before, but now it's going to ask a question. Are they congruent? Are they not congruent? Well, it lined up perfectly. So these are congruent because it was only rigid motions, okay? The other thing that could happen, and I'm just going to change this to something with dilation. When we look at this right here, if we do the rotation, we are taking L to M. So we're going to go 90 degrees counterclockwise again, and we try that out. You can see this point is at 2, -4. We need it to be at 1, -2. So just from the location of it, we should know that we are going to cut this in half. The other thing that you can do is we're looking at this side right here. Hopefully you can see me moving my mouse along that one. And it's 1, 2, 3, 4 units. And it matches up to this side, which is 1, 2 units. So if we're going from 4 to 2, that's going to be a dilation centered at the origin with a scale factor of 1/2. It's half the size. So we've got that half size dilation. That's going to be our scale factor, the 1/2. The two figures are not congruent because a non-rigid motion was used. Okay, dilation is our only non-rigid motion, so that's going to be how that one works out. The congruence and corresponding parts. Again, this is talking about like there's a couple of different things that's going to turn figure 1 into figure 2. So the two figures here, I can tell they are not congruent. They are not the same size. Non-rigid motions are used to map figure 1 to figure 2. The side that corresponds to ST. I believe this is going to be a rotation around here and then the dilation. So the one that matches up to ST should be YW. So I'm just going to type that in as YW. I hit my submit. And there we are. Okay. If you see these, and I'm just going to scroll through some real fast, something like this, we know it's not going to be congruent. They're just going to be similar, similar again. Something like this, these are going to be congruent. So we get that reflection, we get the translation, it matches up. And then it's like, what matches up to YZ? That should be this side here, MP. Okay, that's the second section. Then the third section, congruence versus similarity. It says, is it congruent? I can see this one is not congruent because rigid motions cannot. It is similar because these can. Now remember, this one's a little tricky. If it is congruent, it's also going to count as similar. We just never say that. So you do have to look out for that. But I just wanted to make sure that we could understand and differentiate still between like, oh, this is going to be a weird thing here with the similarity, the congruence, like what's going on. And the scale factor, again, the easiest thing to find, like here's this horizontal 1, 2, 3, 4. And I know that matches it up to this one. That's 1, 2, 3. And it's saying that we're moving MNOP to STUV. So we're going from here to here. So we're going from 4 to 3. We have to multiply that by, here it is, 3/4. We are getting smaller. Has to be between 0 and 1. We multiply by 3/4, and there we are. Okay, so hopefully that gets you through this. But if you have any questions, you can always ask those when I come back. Good luck.